Right now, at exactly this moment, you are standing on a rock, hurtling through empty space, warmed by a star that began as a dying cloud almost 5 billion years ago. What lies between that light and the dark is not empty. It is a history, violent, patient, indifferent. The star at the center, our Sun, is the engine of our solar system. The Sun holds 99% of the solar system's mass. Its core fuses hydrogen into helium, releasing in a single second more energy than human civilization has produced in its entire history. Light you feel on your skin left its birthplace 8 minutes ago. The star is both cradle and dictator. It defines temperature, chemistry, and the possibility of life. Closest to the flame is the smallest world, a battered sphere of rock, Mercury. By day, its surface can climb above 400 degrees Celsius. By night, it plunges below -170. A day on Mercury is longer than a year due to its slow rotation. It carries no atmosphere to speak of, no weather, no voice, only the slow memory of impacts carved into its skin. Next is the planet that once tempted us with resemblance, Venus, the hottest planet in the solar system. Thick clouds hide a surface so violent it is an apt cautionary tale. Temperatures at its surface can be hot enough to melt lead. The atmospheric pressure on Venus is nearly 100 times that of the Earth, clouds of sulfuric acid obscuring any familiar sky. Once, it may have had oceans. Now it is the textbook example of runaway heat, a laboratory for what happens when atmosphere and energy conspire without restraint. Then the improbable, a blue world with liquid water sweeping its surface, a magnetic field that deflects a lethal rain of charged particles, an atmosphere rich in oxygen and history. Our home planet, the Earth. Here chemistry found a rhythm and forged complexity. Earth is, as far as we know, the only planet where life has evolved. Also, Earth is by farthest the most varied planet. But the balance is delicate. Tilt, distance, composition, a set of improbable coincidences that produced habitability. Our red neighbor, the Mars, appears small through a telescope, but speaks in silence. Ancient riverbeds and minerals that form in water tell us this world was once warmer. It hosts the largest volcano in the solar system, Olympus Mons, and canyons. Mars is quite similar to the Earth. One day on Mars is about 24 hours. Also, Mars has an ice shield on the poles and a gravity that is only a bit smaller than here at Earth. Yet it lost its global magnetic shield. The Sun stripped parts atmosphere away and froze the memory of a world that almost supported long-term surface habitability. Then the giant, a world of gas and storms, 50 times the mass of Earth and a gravity that sculpts the architecture of the entire system. Jupiter, the largest planet of our solar system. Jupiter has the second most moons, with over 70 of them counted until now. On Jupiter's surface, a storm larger than our planet has roared for centuries. In Jupiter's core, enormous pressures squeeze hydrogen into exotic metallic states. Its gravity acts as both sculptor and shield, redirecting comets, influencing the impact history of the inner worlds. It is nearly a star, massive, but not enough to ignite. The world is a study in fragile grandeur. Thin bands of ice and rock casting long shadows across Saturn's face. After Jupiter, Saturn is the second largest planet and also has the most moons, with over 270 of them. Its largest moon, Titan, bears a dense atmosphere and lakes of hydrocarbons, places where chemistry runs strangely familiar and utterly alien. But over time, in not too far future, the rings that make Saturn so special will fall into him and vanish, leaving behind only the planet with his moons. Further out, a pale world lies on its side, rotated like a discarded wheel, the blue giant Uranus. Its axis tilt suggests a violent youth, perhaps a collision that knocked it over. Seasons there last up to 42 years, but one day is only about 17 hours there due to its fast rotation. Uranus is quite special because, unlike here, on Uranus, it actually rains diamonds. Temperatures are starlit whispers. The planet's faint glow comes from trapped heat and ancient formation. Beyond it roars the blue giant, Neptune. Wind speeds there can exceed 2,000 kilometers per hour, the fastest in the solar system. The planet completes its long, slow circuit of the star in more than a century and a half. Since its discovery, only 1 year has passed at Neptune. Sunlight is a pale thing here, nearly 1,000 times weaker than at Earth. Storms and dark vortices move across a distant, cold ocean of gas, a reminder that energy and motion persist even where light fades. Past the last great planet, the system becomes a scatter of icy bodies, dwarf worlds, and comets that hold primordial material from the system's birth. This was Beyond Earth, a documentary about our solar system